All right. Hello, everyone. Today is February 10th, 2021. This is the Kubernetes Data Protection Working Group meeting. So today, the main topic on today's agenda is we're going to do the design review of CBT. So Fang is going to lead that. Then if we have time, we can do a quick update on the data protection white paper. Okay, so we can get started. Fang, should I make you the presenter so you can share your screen?
Yeah.
Better, right? Okay.
Yeah, I'm ready. Could you make me?
Yeah, let me stop sharing. So I have made you the co-host.
Okay. So for those who are not familiar with this design doc, we have it. We have the design doc here. I think we can put it on the chat or on the share doc for everyone to read it in later if you like. Today I will present how in this portion of the design doc that specify on how a backup workflow would use this CBT service that we propose here, the CBT API that we propose here to make a backup efficiently or make a restore efficiently, right? So the step of detail, the detail step is all, I listed out here, but to make it more interesting, I did a quick animation of it. So let me present it in the animation fashion to make it more fun. So this is, can you see the slide now?
Yes.
Yep. So this is a typical usage of a block device, right? So when we have an application part that's using a block device, what it does is it creates a PVC and a PV associated with that. And you can, on the back end, on the storage back end, this PV is mapping to a block device, a raw block device in the on the back end, right? So this is very typical use for you know, our Kubernetes environment. And now in the backup workflow, what we do is typically we run a volume snapshot. On the back end storage will create a snapshot, right? For it, and it provides the snapshot handler to the volume snapshot. Then the backup workflow does next is it will create the PVC with the snapshot volume as the source of the PVC, of the data source of the PVC. Then it will mount this PVC, the PVC that's created into like a pod or something to start backing it up, this PVC, the entire PVC, right? So this is a typical workflow. This is very inefficient is that because it mounted and it back up entire PVC, even though only a few blocks here and there have changed. So at this point, if we know that the previous backup exit and the previous backup was mapping with the, let's just say snapshot 0, right? Now we know that the current backup is associated with snapshot 1 and the previous backup is associated with snapshot 0. At that point, the backup solution, instead of backup everything, what it does is it will communicate with the CBT service, providing these two snapshot ID, snapshot 0 and snapshot 1. It will return back, it got back a list of chain blocks between these two snapshots only. So then instead of backup everything, it will then only back up the blocks that change, and this reduce the backup efficient. I mean, it's reduced the number of blocks that it need to back up significantly, and on the chain list that we have here. So this is the backup workflow. Then one of the most important thing in this backup image is that because each of these backup images now have to store additional all the block that it have for the data, but also store the snapshot information, right? This snapshot information is very critical in the restore step, and how to resynthesize, because each of these backup image now is not a full backup image. It's only have a certain block that change. So in order to reconstruct the full image, the backup storage vendor need to have a way to resynthesize this whole disk using this block and the previous backup image, right? So most of the vendor already have that way. For example, for data domain, right? The data domain, we currently at EMC, we have data domain, and data domain already have all of these way to synthesize these blocks from previous image and so on and so forth. Right? So these are vendor specifics. I will not talk about it here. So let's talk about two restore scenario. The first restore scenario is the restore entire disk from scratch and restore to a new disk completely, right? So this typical workflow for this one would be, now we have a backup image in the backup storage, right? What we do is we create a new persistent volume, right? And the PVC associated with it. And on the back end, the back end storage will create some storage, block device associated with them, right? And then we mount this restore PVC on either a restore port or similar fashion. Then we read all the blocks from the backup image to this restore PVC, right? This is a normal workflow, right? However, because remember, this is the CBT backup, we don't have the full image in this and we do not have all the blocks in this backup image. What we need to do is we need to somehow synthesize it with the previous backup that the backup image was based on. So that way we can have a all of the blocks belong to this PVC. So again, the way to synthesize this is vendor specifics. I will not talk about here. So after the PVC have been restored, we unbound it and restart the application. Start the application with the PVC. So now we go back to the inside the whole functioning application with all the data being restored. Right? So this is take advantage of the CBT at all. This scenario, it just fully restore the entire PVC, right? However, if we go into the next scenario where we currently have the working part, the working environment with all the PVC that already there, and we only want to restore to, let's just say 2 days ago, and we want to quickly restore the data without restore all of the blocks, because we know that there's only 2 blocks that change from yesterday and today. Right? So instead of restore 10,000 blocks, we only restore 2 blocks. That where we need to, we want to take advantage of this CBT technology, this CBT API here, right? So the way we do that is that we know that the backup image that we have from 2 days ago is associated with snapshot 0, right? That information is being stored in the backup image. And so what we want to do next is we want to, of course, because we don't want to, we might want to unmount the pod first, or there might be the way to share the pod, the PVC. So let's just say if we don't have a way to nicely share the PVC, right there, right? 2 pods writing into the same PVC at the same time. If we don't have a nice way to do it, the safe way, which is just unmount it, right? Then what we do next is we take the snapshot of the current situation, right? The current disk usage right now. We take a snapshot of it. Let's call it snapshot 0, right? Then we have 2 snapshots on the system, right? Now, with that, then we mount the PVC into a certain restore pod or data mover pod, whatever you call it. Then now with these information about the 2 snapshot, what we do next is we send the snapshot ID, the true snapshot ID to the CBT service. The CBT service will provide us with a bunch of blocks that different between these two, right? The difference between the previous snapshot and the current snapshot. So what we do is we will read from the backup image only the block that is different between the previous backup and the current time. Only those two. As a consequence, instead of restore the entire image from the previous backup, we only might need to restore a few blocks. Right? The blocks that actually change between the backup time and the current time. So after we restore that many blocks, we can unmount the restore block, a restore pod, and restart the application again. So this way is much more efficient. Instead of restore everything, we only install a few blocks. There's one thing that I want to point out here is the block that change between the previous, between the backup image and the current time, the block that change may not belong to the backup image as let's just say 2 days ago, but that block may belong to the data, may belong to the backup image 10 months ago. And the backup storage will have the way to, the backup storage vendor will have a way to provide the specific block for that restore task. And that again is the vendor specific. So I don't want to point it out here, but I just want to point out so to make sure that we are aware that the backup image at the specific time may not contain all the block that you need. You might have to combine it with the previous backup image to get all the block at a specific time. So that is it with my slideshow here. And the step, all the steps are specified, spelled it out here in this doc. So that is it. Pass it back to Xing. Anyone have any question on this one first?
I've got a question. I'm curious, like it feels like this solution relies on the ability to mount any given volume as either a file system volume or a raw block volume, because or I mean, assuming the pod, the application pod is consuming a file system volume, to be able to do the change block tracking, you need to be able to get behind the file system and access the blocks, which, like in general, in Kubernetes at least, the volume is always either a file system volume or a raw block volume. There's no concept of a volume that can do both. So am I misunderstanding that's a presumption that you're making?
I'm not sure I understand your question very clearly. Do you mean that in order to access the PVC, I need to mount it?
Well, I guess, yeah, I want to understand, like for the thing that's doing the actual reading and writing of the blocks from the volumes, whatever that is, it needs raw block access to the volume, regardless of what is actually up above, right?
Yes.
So is that another Kubernetes pod that's doing that, or are you presuming the existence of something else that can perform direct I/O on the volume that's outside of Kubernetes entirely?
So the scenario that I present here is just block device all the way, right? It's not mapping it's not mapping into file system block PV or PVC, whatever. It's just all block device. So I assume that with the block device PV, we can mount the raw block PVC onto the restore pod or backup pod as a raw block device, and you can directly read and write into this block on the restore or backup pods as a raw block device.
So if this whole solution is only aimed at like raw block volumes in Kubernetes, then I understand how it would work.
I think this is only, I think you created a different PVC, right, with the raw block mode just for this purpose. But the original PVC could still be using file system mode, right?
Okay, yeah, that's what I'm trying
Fang,
to get at here. So you're saying
okay.
the
Yeah,
game we
Fang,
can
can you
play is
clarify? Yeah, I believe that's the
two
case.
different
Fang, please
PVCs.
clarify.
Yeah, so the PVC that we are being backup is this PVC on the left, right? It's untouched, right? This untouched. And when we backup, we create a snapshot. This will then we will create a new PVC with the snapshot as a data source. So when we backup, we're not touching the original PVC. We're just working with the PVC snapshot here.
But
Right, but if the original PVC was a file system PVC, you're assuming that you can convert it to a block PVC when you restore from a snapshot.
So that is a different
yes,
workflow.
yes. No, but
like I
Fong,
said,
that
in
is the
this,
assumption, right? So I mean, first is yeah, when you do the snapshot, it's a separate volume. So even if the original PVC was a file system PV, the volume snapshot could be mounted as a block PV.
Yeah, I don't know if CSI allows that. I mean, maybe it should if it doesn't, because this is very interesting.
It creates a different one. Then it's the different one, right? So it's not
as
the
a
original
matter,
one.
as a matter of
We're not
fact,
changing the original one.
No. What I'm saying is, like, I thought that Kubernetes had protections, or sorry, CSI had protections. So if a volume has a file system mode or whatever we call it at the CSI layer, and you take a snapshot of it, and then you later try to turn that snapshot into a raw block volume, that you would be prevented for some reason. I might just be hallucinating that, and maybe that doesn't exist.
I think this works, but I mean,
okay.
yeah, but I don't know the details. I don't know if you have to do some workaround for this to work.
it actually works. We have experiment.
Okay.
And we found
basically
out
you just
that
need to create so you just need to create a PVC that's different, that has a different mode.
So
from the original
yeah, for
that work, right? Okay.
Just to
we
clarify,
have experiment on one of our Dell storage. It's PowerFlex, and we have done experiment using. So the left-hand side, the PVC on the left is a file system, but in the back end is a device. We create a snapshot of it, and then on the restoring path, we use the PVC. We create a new PVC, but this PVC is not a file system. We can use the block PVC, and we're still able to mount this snapshot here, because on the back end, the snapshot we have here is actually a block snapshot. So we were able to do that.
I get that. I get that.
But I do have a question though.
CSI API allowed this, so I'm trying to figure
yeah,
out.
so I think that is,
imagining.
yeah, I believe that some people try that is actually allowed. But I guess my question is, eventually when you finish the restore at the end, you have to go back to use the original setting in your PVC, in your original PVC, right? You can't be, I think this is like just temporary. You're reading data in this mode, this is faster. However, at the end, when you finish your restore, you have to go back to the original mode. Otherwise, I thought the application will not function properly, right? Fang?
Yes.
Okay.
I think we, to be fair, I haven't experiment all the way. I haven't do all of that. I think Thomas have done some of it. I don't remember exactly if he has restore working also, but I know for sure that he have done the backup side. But
yeah,
in
Xing,
theory we can. In theory we can, because if we do in the restore data path, we go the reverse direction. Eventually we end up with a block device on the back end here, right? Then we can create the file system PVC using that. But again, I haven't personally experimented that, so I cannot say for sure.
Hey, can I ask a question here? Hi, this is Raghu from Catalogic Software.
Yeah,
so
go ahead.
I want to go back to Ben's and Xing's question, right? So not restore, this is backup. So I have a file system PV. You take a volume snapshot and then you create a PVC based on the volume snapshot. I don't know if there's a way to say change the type. I mean, you're just saying the source for the PVC is the volume snapshot. That's all you can say, right? You can't change the type for the PVC there from file system to block, at least as far as I can tell.
So I'm reading through the specs now, and I can't find anything at the CSI layer that would prevent this. So now I'm looking at the Kubernetes API to see if the Kubernetes API allows it. Maybe this is just something that just works, and it's by accident, because I don't think we intended this. But it's cool.
I know that there are people who have been doing this, so definitely this works. And so it's not.
Okay.
So, Raghu, is your question about snapshot or create volume from snapshot?
No, my question is exactly the same as what Ben was asking.
Okay.
How do you create a block PVC from?
Okay, I think that we need. So we are only talking about the volumes backed by log actually. So
Oh no, okay,
that's like you mount it as file system or raw block, right? That's what Fang was talking about. We are actually right now for the CBT. Right now we are not talking about adding that support for file yet because that's different. That's like a change files. That's completely different.
Right, but no, I'm
maybe,
not talking.
Maybe
I think
you want to.
Yeah. So for the purpose of this, the flow that I present today, it should block all the way. So it's
can you maybe go to the beginning of this? Just talk about like what we want to support and what is out of scope for now. So
no, the block device is okay. You're saying the original PV must be of block type.
No,
you can map either as file system or you can mount either as file system or raw block, but underneath it has to be a block. It cannot be this is not like a file share backed volume.
No, that's agreed. Yeah, that is clear. I think it should be backed by a block, but the point here is at a user level, right? I'm creating a persistent volume type file system. And then for my backup, I'm creating the first thing I do is create a volume snapshot, right? That's the first thing I have to do. After creating the snapshot, the next step shows create a PVC from that snapshot, right? Now, when I do that in that flow, I don't think either Kubernetes API or CSA API allows me to say, give me access to a raw block device in my pod.
So when you create a snapshot, there is a volume snapshot handler. You can use that volume snapshot handler to create a PVC from that. And with that, you can specify a block.
You can? Okay.
A block PVC from that. So you might want to look into the volume handler of how that being used. But
are you sure?
I
thought you have to use the.
Can we talk about more fundamental issues? I think we can test this and verify this, but I have some more high level questions about this design.
Okay.
If there are no objections. So basically what you're proposing is that we want to make a distinction between snapshots and backups, right? In a way, snapshots are a baseline for backups, but backups through the CBT service, we want to make it more efficient by just sending the deltas. That's basically the gist of what you're proposing, right?
Yes.
So that leads to a few questions. One is basically we're going to expose backup as a new, through a new API as opposed to leveraging existing snapshot APIs. Is that what we're eventually getting at?
APIs still.
So
maybe Fang, can you maybe just go back to that Google Doc, go through that first? I think there was some confusions, just like requirements and things like that. So I think he's still going to use he will still take volume snapshots, but then in addition to that, he will also make an additional call to get the change blocks. So you still need
we do not change the backup, how the backup being done actually. We only add the snapshot information so that when we do the restore, we can do it more efficiently. That's it.
You also, Fang, you also need that at backup time, right? The backup time, you also need to get those blocks, and then you need to send that to your backup device, right? That's needed at backup, not just at restore time, right?
The detail of backup, how the big backup image being saved is up to the vendor. Actually, we don't spell out exactly what vendor should save. But at least in order to restore, if we want to do the restore efficiently with the CBT, then it should also save the snapshot information also.
So let me ask you this. So look, if I'm a CSI plugin, and then, you know, if somebody tells me take a snapshot, I'm going to take a snapshot and send all the data to, let's say, some cloud store somewhere else, you know, if it's like a cloud type snapshot. If somebody tells me to do a backup and that backup implies a snapshot under the hood, as a CSI plugin, I'm going to do the same thing. Like, what is preventing me from sending all the data? And, you know, your CBT workflow is getting involved and sending only the deltas.
No, if I understand the question, then correctly, then the backup vendor can choose to use the CBT or not. The CBT is just a guidance for you to back up more efficiently. That's it. It should work with your existing backup workflow, right? If you want to send out all of the block to the backup storage, you can go ahead and do it. But if you want to do it more efficiently, you might only need to send the block. You only need to back up the block that chain. That's the only enhancement here. If there is no previous snapshot, for example, right? If it is the first time doing backup, there's no previous backup, then obviously you need to back up all the blocks. It's only help with it only help when we know that, hey, there's a previous backup if there's a previous backup that they have a snapshot information have done before, and then we can base on that and do the like an incremental backup.
Yeah, I think it's important to mention that there is no backup API. I mean, to the other caller's question, there's no requirement for a new backup API here. That's not being proposed, if I understand correctly.
No,
Right,
yes,
yeah.
of course. There's
So
we don't
API.
propose any
And
new.
then also the CBT API, right?
Yeah.
Right.
So only new thing what I see it here in this proposal is basically a CBT service which is going to return the change block for any given two snapshots. There's only one snapshot. It'll return everything within that snapshot, right? That is the add-on things.
I guess, you know, basically the model we're assuming here is, for example, like for cloud type volumes, when you do a snapshot, that implies, you know, pushing the volume data to an object store. You know, for those type of things, for those type of backends where the snapshots are remote copies, we're going to be ending up with two copies: one generating by the snapshot by the CSI plugin that generates a snapshot, and one by this backup service that does its work behind the scene, right?
Oh, I think the backup service will have to have like two different ways for different type of storage, right? So if you already upload your snapshot somewhere to object storage, then that's already a backup. That definitely will be different from cases when you have
so that would be like a secondary copy of the snapshot.
Yeah, so I'm saying this is different. You will have to design them differently. It's just impossible to have one code path for this two types of storage.
Okay, so now this makes sense. And that leads to my next question, which is the restore. So basically, I mean, given that for each backup, there's a corresponding snapshot, right? Most likely, when a disaster happens, we're going to use the snapshot copy for restore, unless, you know, that restore copy that snapshot copy is gone. So we have to restore from the backup set, right? And my question is, how does CBT get involved during the restore workflows? Because
go ahead.
Sorry.
So in this case, the assumption is being raised that the backup vendor has synthesized the full backup from the CBT, right? So the copy that's on your backup storage is a copy of the full backup that was synthesized using the previous full and all the CBTs.
Right, but my point is this. Let's say, I mean, obviously, like the main benefit of the CBT service is that we're only sending the deltas, right, when a backup happens. So the backup happens faster. Right, and it's also more space efficient on the,
right.
You know, so there is a trade-off, because when we do restore, we don't pull all the data right away. All the data is not available right away. We just have to incrementally pull them right from the backup source.
No, I think that's a wrong assumption.
Are you
No,
saying
thank-
restore from a backup device is slower than restore from a local snapshot? Is that what you're trying to say? Or I'm not.
I mean, first of all, I'm trying to understand exactly. Look, I mean, it seems, you know, backup is a secondary copy of a snapshot, right? So
Right.
if the snapshot copy is available, we would use that for restore because that's
Right, you can,
efficient
yeah,
than
you can
going
use
to
that,
the
right? So that's that. I think that's a different way, right? I think here this is more talking about like.
Yeah, we don't restore to a snapshot. We restore to the block device itself, right?
Right. So I mean, here the
No,
backup.
No, I understand that.
Yeah, I think you can definitely have like another tool just to back up from your you restore from your local snapshot, right? You could have that, but I think here we're really talking about the data has to be uploaded to somewhere to a backup device. I don't know whether we want to like accommodate both in the same solution. Not sure. Yeah, but I definitely that's also useful, right? Because then that way you can actually restore quickly. If you still have your local snapshot, of course, that's much quicker than you have to download from someplace else.
I think the scenario that got mixed up a little bit here is that we, from his question, we always have two separate devices, right? The backup storage device and the current storage device that the customer might have in, you know, to do the production environment, right? So these when we restore, we assume that the backup vendor would able to synthesize all the blocks belong to a certain backup image. We assume that because a lot of backup vendor providing that service right now is Data Domain is one of them that I use. I think AWS also have the way to synthesize your whole disk. It's just a bunch of blocks, right? So, and then your question related to how the CBT being testing advances here. If we restore the entire PVC, then the CBT does not provide any advantage here at all. It just copy all the block from the backup storage back to the storage. There's no advantage. It's just a bunch of blocks. If the only difference is that if we want to restore only specific blocks, then that is where the CBT can provide the advantage that if you want to, if you know for sure that from yesterday until today, there's not a lot of data change, right? And then you run the CBT service restore, then that restore only the block that changed from yesterday to today. So only these few blocks will be restored, and then you can go back to your yesterday image very quickly. Instead of restoring 2 terabytes of data, you only need to restore a few blocks, end up with a few megabytes. That you can have your production environment back and running within a few minutes instead of a few hours of restore.
Yeah, the part that doesn't make sense to me is this. So, I mean, I think we should talk about also the restore workflows. So let's say from the Kubernetes point of view, if I want to do a restore a volume, I would imagine, look, are you proposing to have like a new volume source, which instead of a snapshot is like a backup image, or are we still relying on leveraging the same snapshot as a source? Look, first, what's the workflow here?
So in this case, so we are taking a scenario, right, where the primary storage is lost. So you will be creating a new PV, a PVC, and then this PVC will be mounting on the pod, and the pod will read data from the backup storage and write back to this.
So what would the volume source of that PVC be?
Yeah, I
So
think that's where the data populator feature from Ben, right, proposal that helps there. The data populator for PVC.
Okay,
so yeah, so I mean, so it's a pod, right, that will be finally writing it. So you create a new PV on this new storage, and then PVC and then mount it to a pod, and this pod can now go read from the backup storage. I'm guessing the pod will be from the backup vendor. It will go read from the backup storage and write to this PV. So
right.
it's still a normal data path in terms of Kubernetes and CSI. It's
right. The flow sounds right, but I think this is where, like I mentioned, what will be the source of the PVC? So it won't be a regular PV or a snapshot, but that is where you can say my source.
It's a new empty PV, right? I mean, you provision a new PV, and then you populate that.
No, that is true. But the PV is not ready until all the data is written to it, right? All the data is restored.
Yeah.
And for that, you need a new source, basically. It's the existing source definitions won't help.
So that's what he's saying, right? I mean, the backup software, whatever, it will create that provision a new PV. It's a new empty PV. And then you mount it to this pod. That's what you're seeing on the slide. And the pod is your populator. It will go read from your backup storage and write to this PV.
Yep. That's the.
I want to clarify one thing here with Vaughn, please. So the assumption is the primary storage will be lost. I'm wondering how this will work if this is the assumption. Because if we go down to the next slides, right, the first step is actually to take a snapshot on top of the existing PV.
Yeah, so this won't apply, obviously. So it will be the first case in the restore where you just restore the whole backup, but you're still gaining the efficiency on the backup side, right? I mean, your backups are fast, even if during restore you are restoring the whole volume.
Sure. It depends on how you implement backup, of course, but some storage vendors already, provide only store the deltas for the snapshots by themselves. I kind of agree with the previous point where the restoration cases may not necessarily fit into the efficiency piece. The efficiency piece may not necessarily fit into the restore case, especially for when you lost the whole storage system. Because that way, you might well have your snapshot already ready on the snapshot system. Why do you even bother to calculate the change blocks?
Right.
Yeah, I think change block is mainly for the backup. At backup time, it's faster. At the restore time, you would still have to. Well, I think Fang also mentioned some like incremental restore some time ago, right? If it's like, if your production system is still there, maybe you just want to roll back or something. I remember he mentioned something like that. But if you really have lost everything, you have to start from scratch. Of course, you have to do a full restore.
The
issue with incremental restore is that it depends on the data access patterns, right? Or
yeah, I think last time when he presented that one, I think there was also a lot of questions on the
It's actually true that if we lost everything and there's no efficient, there's no way to can use the CBT service here to do anything. This is restore everything, right? All the this is like an incremental restore. Instead of restore everything, if you only need to, your system is still running, but you only need to revert, one part from today to previous day, right? With the data of yesterday.
Well, but I think this still helps restore because, but of course, then the backup vendor will need to be able to know how to merge, the first full backup with all the deltas, so that at restore time you can do one full restore with the combined image. Right,
yeah.
So it still helps.
I think a lot of people do that already. Yeah, I think they probably already have. I have a question about the CBT service. Is that Kubernetes level API? I mean, right? The CBT service shown in this diagram.
We're still proposing it. We're not.
The proposal is for a Kubernetes API, right? That's the proposal itself is to provide this as a Kubernetes level API. I think. Right?
I guess the bigger question is this, like whether these backup images are going to be like some standard format, because if it's a standard format, then you can have a generic CBT service that can handle, different kinds of volumes. But if the backup images are proprietary, and each backup vendor has its own image. Then each backup vendor is going to have their own CBT service. And then I think that's going to be an issue. Look, what's the plan here?
I think we're going to need both. I mean,
no, we don't have a standardized for the backup image format. We only, in the CBT, we only specify block that change. I think I have, let's go back to the document here. I think we propose, after we look into the CBT service that on the existing vendor like VMware, AWS, Microsoft Azure, and we proposing this CBT API here, and this only spell out the chain from a certain offset to a specific size. So this is the list of chain. Each of the block, we just only spell out the offset and the size, and we do not touch how the backup image is formatted. That's up to the backup vendor. That's the answer. Yes, answer your question.
As you said, basically it's just like a diffing service. That
would there be a way to do identify optimizations out here? For example, within the change block, if all those are zeros or something like that.
I'm not sure I understand your question. Could you repeat that?
So the question is about this change blocks, and is it possible to find out the blocks are sort of optimized or it can be optimized by certain properties? For example, the entire block is all zeros. So in that case, backup window does not have to read that being all, entire block is zero.
That's probably not changed, right? Is that means not changed, then probably you shouldn't get that as part of the change blocks.
That could be changed. I mean, there was something and it became zero now.
Either that, or is there going to be any way to find, like on the first snapshot, blocks that have never been touched, never been initialized?
That is another probably optimization which backup vendors can be really benefiting.
Oh, I think what you meant is, like, for example, the chain block. Let's just say I have a disk that block number 5 chain, but the new data now is 0. So instead of the vendor have to copy a new block that contain all the 0 from the storage to the backup vendor to the backup storage, if there's any way we can optimize that to tell the back end that, hey, that chain by just delete the block instead of copy the whole block of 0 over or something like that, right? My answer for that is up to, I don't think we should specify such a specific case for our optimization in the API, especially for the first attempt. This is really our first attempt to do that. That's is up to the vendor then.
I think we discussed this a little bit before. I have another question, which is the deletion workflow. Right. One of the things, one of the concerns I do have is it seems that the CBT service will have to be in the business of managing life cycle of snapshots. And unfortunately, snapshots are managed also out of bound as well by warm snapshot objects. Right. What is the conclusion on that? Do you still remember?
Isn't the deletion handled by the storage itself, whichever is backing up the snapshots?
Well, you need to create snapshot objects to create the snapshot itself in the beginning. And then this
Right.
lifecycle.
Right. I thought you were
Oh, so
asking,
that
let's say
I
you created
think-
3 snapshots and you deleted, let's say, middle snapshot, right? Is that the question?
I think I remember the question as this. So basically, we have two entities here. The snapshot on the backend storage and the volume snapshot object and the volume snapshot content object on the Kubernetes cluster.
Yeah.
These are the, so I think we talked about that before, that we don't need to maintain the Kubernetes object. We don't need to maintain the volume snapshot object and the volume snapshot content object. We only need to maintain the snapshot ID of the backend storage. That's where we need to provide for the CBT service to take the different snapshot between the two.
Sure. Is the ID obtained via creating the Kubernetes worm snapshot object, or you plan to code CSI directly?
So the snapshot ID that we have here, snapshot ID 1 and snapshot ID 2,
Yeah.
the name of the volume snapshot object or the volume snapshot object content. But
Okay.
it is
Then that was my concern.
So hold on. I think here what we proposing here, those are CSI interfaces here, right? We're not talking about Kubernetes. Is this a Kubernetes API you're talking about? Okay. Okay. All right, then that's different.
Yeah. So because the
okay.
object, the volume snapshot object itself can come and go, right?
Sure, but if I put a worm snapshot over there, then the real snapshot ID in the storage system might get deleted out of bound. That's what I'm saying.
Yeah. So Fong, so this snapshot ID is the snapshot ID of in the underlying storage, right? Not the. But you're saying this is the volume snapshot name? No, right?
Oh, not the volume snapshot name. It is the underlies whatever the storage vendor provides us, right?
What do you mean? The storage vendor won't provide you this, right? The caller needs to provide you this. Now my question is, I as a caller of the CSI interface, where do I get this snapshot ID from?
Oh, so the backup vendor will need to keep track of this, right? Because backup vendor will be the one, the backup software, right, will be the one who is creating a volume snapshot. It will get a volume snapshot content which has the snapshot ID. So it needs to track those basically, right?
Yeah. So the
I think before tracking, we need to, the question is how to retrieve this for tracking purpose.
Well, so because the backup software will still be creating a volume snapshot API object, which will generate a content that will have the snapshot ID in there. So at that point, the backup software will need to save that ID somewhere.
So
this is
CSI snapshot interface basically.
Yeah.
Okay.
Now, when you say backup, is the CBT service a community maintained one, and that one will be will be responsible of creating volume snapshot and code as a CBT API?
I don't think that should be doing that, because then then that means we are actually providing a backup software. I don't think that's the plan, right?
Yeah, because the slides show so. So I was like asking.
Okay. Yeah, that slide, maybe that's the kind of merchant. I'm not sure. That slides is that should be like a sidecar, right? It should be a sidecar. Then you call it. You provide this. So okay, so it's like
we have 5 minutes left. So maybe how about this? We can continue that discussion in our CBT group meeting.
Yeah, that sounds good.
Yeah,
we
sure.
will follow up with that there, and then today we just want to present the backup and backup and restore workload and how they take advantage of the CBT service that we're proposing. in there to make it more efficient. And we can, because this is not, we haven't finalized this yet. So hopefully,
Yeah.
next in our team meeting, we can discuss in detail, and we can answer all of these detailed questions there.
Thanks, Juan.
Yeah, thank you.
Yeah, I think the way I look at this is, given that backup is the background workflow. So for example, whenever we have a volume snapshot content that is ready and it has a snapshot ID, that's a signal to the backup workflow that you can start processing this snapshot and back it up, right? And as far as like backup deletion, I think that can be completely independent of life cycle of a snapshot. Because backups, they have their own life cycles. You can back up your snapshots for 30 days or 90 days or 1 year. So they shouldn't be completely coupled with the life cycle of snapshots, and they should get managed through the backup workflows. If you want to delete the backup, you should just do it through the backup interface.
Yeah.
Just completely outside of Kubernetes. So I think that's basically the way you should have.
I think we need to, I think we need to draw like several different boxes on that diagram, right? So what is the responsibility of maybe CSS sidecar, and then you also have a backup software that is orchestrating all of this, right? So yeah, I think we need to have those details sorted out. Okay. All right. Thank you, Fawn.
Thank you for all the feedback and question. Actually, we will need to take all of these questions back to our team meeting and talk about more. Thank you very much.
Thank you. Okay, so next we just want to talk just a couple minutes on the data protection white paper. Tom, you have an update on this? Is Tom still here? Maybe he's or
yeah, I can respond a little bit on this. I think he got started, but not too much progress at this moment.
Okay. Yeah, I thought he was here earlier. Okay, because
yeah, he was here. He was
he just dropped. All right, that's fine. Yeah, I think he's started to do some work on the quiesce, unquiesce section. I think he just started. There is Tom.
Yeah, I'm sorry, I was having audio issues. So I added some content, and feedback is always appreciated. I think we still want to make some of the pseudocode have kind of a common voice, so we need to pass at that. But feel free to add comments as we're going. They're linked. I'll link them here, but they're also linked in the main document.
Okay. Thanks. All right. We have 2 minutes left. Anything else? Anyone want to talk? All right, if not, that's it for today. Thanks, everyone.
Thank you.
Thank you, everyone.
Bye.
Thanks, everyone.
Thank you. Goodbye. Have a good day.
Bye-bye.